like, share, subscribe.
Hey y'all, welcome back. Today we're working on homework 9.2, and really all we're doing here is just solving polynomial inequalities. So the strategy we're going to use here is we want to first find the zeros of the polynomial and then find out whether or not the function is positive or negative in between and outside of those zeros. So let's start with this one. Off the bat, we get a tricky one to factor. Here, we've got a quartic here, but one way you can think about this is kind of like how we did in the logarithm unit, is do a little u substitution here. So I'm just going to make a little note here that I'm going to let u be x squared, okay? Or here, there we go. And so it'll just make this a little bit easier to factor if I rewrite this as like u squared minus 17u plus 16. Now it just looks a little bit more like what I'm used to factoring. And then once I actually figure out what the factors are, I'm going to go back and substitute this back in. So from here, we get let's see, two numbers that multiply to give me 16 and add up to negative 17 is going to be negative 16 and negative 1. So I'm going to have u minus 1 times u minus 16 is greater than or equal to 0. Oh, whoa. What happened there? Okay. Now, at this point, I've got the factoring done, so I can go ahead and make my replacement and replace that u back with what it is, which is x squared. And so what I get is x squared minus 1 times x squared plus 16. Okay, so at this point, I should be able to figure out what my roots are by setting each of these equal to 0 and solving them individually. So from this first, that should be a minus. My bad. There we go. So what I'm going to do is I'm just going to say, okay, so my roots are going to be, like if I add 1 and then take the square root, I'm going to get plus or minus 1. So I get 1 and negative 1. And then same thing over here with this one. If I add 16 and then take the square root of both sides, I'm going to get plus or minus 4. So I get positive 4 and negative 4. Now once I have my roots, I can draw my number line to help me figure out where is the function positive, where is it negative. The roots that I have labeled here, I've got negative 4. Wow, so we're going to have quite a few intervals here, aren't we? Really starting off strong. Then we got 1 and we got 4. So we got a total of 5 intervals here. And I'm going to pick a representative from each interval, plug it into x, and find out whether or not it's positive or negative. So a number less than negative 4, I'm going to go with, let's say, negative 10. And if I plug that in, I'm going to get a positive times a positive, which is positive. So I know that this interval right here is positive. Okay. And then in between negative 1 and negative 4, I could pick a number like negative 2. So maybe I'll make a note here. So here are my representatives. I'm going to pick negative 10, which is the one I just did. For this interval, I'm going to pick negative 2. For this interval, I'm going to pick 0, and then 2, and then 10. And what I'm doing here is I'm plugging this back into the equation and figuring out whether or not the function's positive or negative. So I don't really care what exactly it equals. I just want to know if it's positive or negative. So when I plug in negative 2 here, I'm going to get 4 minus 1, that's positive. And then if I plug in negative 2 here, I'm going to get a negative. So I get a positive and a negative. Positive times a negative is going to be negative. In between here, I'm going to plug in 0. So I'm going to get a negative times a negative is positive. If I plug in 2, I'm going to get a positive times a negative, so that's going to be negative. And if I plug in 10, I'm going to get a positive times a positive, so it's going to be positive. So at each of these x values, the value of the function is 0, which is important for this particular question because it's saying when is the function greater than or equal to 0. So we want to include not just the intervals for where it's positive, but also include these endpoints where it actually is 0. So the way I'm going to type my solution set is I'm going to say x is an element of, and I think I was having trouble with this on the, I want to say, hold on, let me pause this real quick. All right, there we go. So this is the element symbol. So anyway, x is an element of, and now we're going to list all the sets where the function is greater than or equal to 0. So that's going to be between negative infinity and negative 4. And because it does say equals to, I'm going to include negative 4 in my set. So to indicate that, I'm going to put a bracket. And then I have union, because there's multiple sets here that I need to join together. And then the next one will be between negative 1 and 1, including negative 1 and 1, because those are both 0 at those points. And then the last set here is going to be from 4 to infinity. And so in each of these sets, any number that exists in any one of these three sets is going to satisfy the inequality. So there's number 1. Let's move on to number 2. We're going to basically do kind of the same thing here where we find the zeros, create our number line, pick the representatives, and then write our solution. So it looks like this one's a cubic, and it doesn't look like I'm going to be able to factor out a GCF here. We do want to make sure that our polynomials are set equal to 0. So I need to add 12 to both sides. And then I'm going to try to factor this. Now, because there's no GCF, I'm going to be kind of stuck factoring by grouping, which with a cubic works kind of similarly to how you would factor by grouping in a quadratic. It's just that you don't have to actually like split up any terms. You're just going to group the first 2 terms and the last 2 terms and go from there. So from looking at the first 2 terms, I see that my GCF of those 2 terms is x squared. So factoring out an x squared will give me x minus 3. And then the GCF of my second one will be negative 4, which will leave me with x minus 3. Now if you're doing this correctly, then what's inside the parentheses should be the same. So notice we got x minus 3, x minus 3. That is going to be one of our factors, and then the other factor will be a combination of the 2 GCFs you factored out, so x squared minus 4. So now we've got this factored as far as we need to, so we can find all of our roots. So my roots are going to be at 3, and then let's see here, square root of 4 is 2, so plus or minus 2. So now I'm going to create another little number line, kind of like this one, in fact, so that I don't have to redraw everything. I'm just going to steal this number line. I'll change the values and everything to be what I need them to be. So let's delete. Yeah, I don't know if I'm really going to save much time by doing it that way. But yeah, let's get rid of all this. We can get rid of one of these because we only have 3 roots here. So we've got one at negative 2. I guess let's go ahead and erase these. We've got one at negative 2, which should be like all the way to the left. Negative 2, and then 2, and then 3. Okay, so now we're going to pick our representatives. Negative 10, I guess that'll still work for this outside one. And then between negative 2 and 2, I'm going to want to use 0 here. 0 is usually like kind of my go-to if I can use it, just because it's so much easier to calculate than anything else. In between 2 and 3, I'm going to have to pick something like 2.5. And then on the right-hand most interval, I need to pick a number bigger than 3. So I'm going to just go with 10. All right, so as I plug these in, let's see, negative 10 minus 3 is going to be negative, and then 10 squared minus 4 is going to be positive. So if a negative times a positive, which is negative. For right here, if I plug in 0, I get a negative times a negative, which is positive. If I plug in 2.5, I get a negative times a positive, which is negative. And if I plug in 10, I get a positive times a positive is positive. So if the question is, when is this less than 0, I'm going to list out all of these negative intervals. So my solution will look kind of like this. And in fact, I'm going to copy and paste this. So I don't have to find that, that element symbol again. And so we're looking to see where it's negative, right, where it's less than 0. So it'll be between negative infinity and negative 2. And this time I'm going to have a parenthesis instead of a bracket because it is strictly less than. It is not less than or equal to. And then the other, I only have one other interval that's going to work here, and that is going to be in between 2 and 3. And so those are my two intervals. And this will be my solution set. So there's number 2. Let's take a look at number 3. Now this one might be a little easier to do. Kind of wish I started with this one because this one has a GCF. And so it'll just make the factoring a lot easier if we factor out that x squared first. So x squared times x squared minus 7x plus 12 is less than or equal to 0. It looks like I can factor out that binomial. We've got x, let's see, so two numbers that multiply to give me 12, add up to negative 7. That'd be negative 3 and negative 4. So my roots are going to be at 0. Do we have a multiplicity of 2 there? So as far as like coming up with the signage, you know, I might even just make a note there. What that will, since we're going to have a bounce on the x-axis there, what that will look like when we're creating our number line is that the sign actually won't change on either side of 0. So we can expect, like if it's negative to the left of 0, it should also be negative to the right of 0. And same thing if it was positive. I'm not sure what it's going to be yet, because I haven't gotten that far, but we'll see. So we've got 0 is one of our roots, and then we got 3 and 4. So basically what I'm saying is this interval will have the same sign as this one. If you just have an odd number, a single root, it will alternate like this. But if you have an even multiplicity on one of your roots, it should, we'll double check, but it should be the same sign. So as far as my representatives are concerned, I guess I'll pick negative 1 if I can. Yeah, let's do negative 1 for that leftmost interval. And then for this interval between 0 and 3, I guess I'll pick 1. Between 3 and 4, 3.5 is probably the way to go. And then on this last interval, I'll just pick 10. So if I plug in negative 1, I get a positive times a negative times a negative. So positive times negative is going to be positive. And since I have that multiplicity of 2 on this root, I'm expecting this to be positive as well. So 1 times a negative is also positive. So that does happen. So basically what's happening on the graph here is it's coming down, it's hitting the x-axis, and it's popping back up. So between 3 and 4, if I plug in 3.5, I get a positive. Actually, this is always going to be positive, so I almost don't even need to check this x squared for each representative. But anyway, so I get a positive times a negative is going to be negative. And if I plug in 10, I get a positive times a positive, which is positive. So the question is, when is it less than or equal to 0? Now remember, these are all zeros. So if it's less than or equal to 0, we want to include the endpoints here. But really, the only place where it's negative is in between here and here. So my solution set will be all the x values in between 3 and 4, including 3 and including 4. And so to notate the fact that we are including the endpoints, we will use brackets. So say between 3 and 4. And there's our answer for number 3. So that's the end of the first page. As soon as I get this box in a little bit more reasonable size, we'll move on to that. So did it not give me the box? Oh, there we go. Okay, so there you are. There's 1, 2, and 3. Let's take a look at number 4. With number 4, thank goodness this thing is already factored because the last couple of questions were kind of troublesome to factor. So, so here we can go straight to our roots. Worrying about it too much. Our roots are going to be, looks like negative 3/2. Okay, so negative 1.5. And then, and that's going to have a multiplicity of 2, just as a little note. That way we are not surprised when the sign doesn't change on either side of that root. And then we have x equals 5. So I'm going to create my number line. I'm going to plot out -3/2, which is really -1.5, if that makes it easier, and 5. So the representatives I'm going to use here, see something less than -1.5, I'm going to go with -10. Usually 10's like an easy number to deal with. And then 0 in the middle interval, and then on this interval out here, I guess I'll choose 10. So now, I'm going to multiply, as I plug these in, we've got this -3 hanging out there. So this is just going to be -3 every time. It's going to be a negative times something times something. This being squared, this number is always positive. So we don't really need to test this at all, because we know this will always be positive because this equals 0. This equals 0. Because we're squaring it, right? And when you square a number, it always becomes positive. So we've got a negative times a positive times whatever this happens to be depending on the representative. So if I plug in -10, I'm going to get, this will be negative. So I'll have a negative times a positive times a negative will be positive. I'm expecting the sign to not change at that root because of that even multiplicity. So hopefully that turns out the way I think it's going to turn out, but let's see what happens when we plug in 0. So if I plug in 0, I get a negative times a positive times a negative, which is also positive. So we do get that behavior where the sign is not going to change because we've got a bounce occurring here. And then for, let's see, over here we're plugging in 10, so we have a negative times a positive, so that's going to be negative here. And if the question is, when is this greater than 0, you want to be careful. Don't be tempted to say like -infinity all the way to 5, because right here, this is a 0, okay? These roots are where the graph hits the x-axis. So the function's not going to be greater than 0, because 0 is not greater than 0. So we will list these two intervals separately. Okay, we won't list it as just like one interval. So I'm going to go ahead and grab a similar solution set here, so I don't have to retype everything. You guys know the deal here. I'm all about copying and pasting. And so our solution set will be from -infinity to -3/2. And then also from -3/2 to 5. All right, and there's number 4. So let's take a look at number 5 as soon as I can improve this. You know what, I'm just going to erase it and redraw it. I don't know why it's giving me such a hard time trying to resize that. All right, so there's your solution set. For number 5, oh wow, we don't have a ton of stuff going on here, but we do need to subtract 48 from both sides. Remember, we do need a 0 over here on the right-hand side. So I get 3x to the 4th minus 48 is less than 0. I believe we can divide out a 3 here, right? Pretty sure 48 is divisible by 3, and so if we divide both sides by 3, that will simplify to be x to the 4th minus, what would that be? 3 goes into 4 one time, carry the 1, goes into 18 6 times, so it should be x to the 4th minus 16. This is a difference of two squares, so we can factor this as x squared minus 4 and x squared plus 4. I guess we don't really need to do that because we could just add 16 to both sides and take the 4th root. But this might make that go a little bit easier. So my roots here are going to be, if I add 4, that'll give me x squared equals 4. And if I take the square root of both sides, I'm going to get -2 and 2. And then here, well, this is going to turn out to be imaginary. Okay, you don't really need to know what it is. So really, I'm just going to list the real roots. Okay, There are two imaginary roots here that are not going to affect, they're not on the number line, so they're not going to affect how you write your answer. So the imaginary roots, which I'm just really noting here just for your information, are going to be plus or minus 2i. So negative 2i and positive 2i. But you don't really need to deal with these. You can just list these two, and that's good enough. When we draw our, here we go. When we draw our, trying to stay consistent with the colors here. Draw our number line. The two real roots that we have are negative 2 and 2. You can just ignore the imaginary ones. So the representatives that I'm going to pick are going to be, well, I'm just going to stay consistent. So I'm going to go with negative 10, 0, and 10. You guys know those are kind of my favorites. 1, 10, 0, if I can pick any of those, I'm going to. So let's plug these in. If I plug in a negative 10, this is going to be a positive number times a positive number, so we get positive here. We don't have any multiplicity, so I'm kind of expecting this to alternate, but I'm going to check just to make sure that I don't get anything wrong here. If I plug in 0, I get a negative times a positive, which will be negative, so it matches up with my expectation. And if I plug in 10, I'm going to get a positive. So the question is, when is this less than 0, or when is 3x to the 4th less than 48? That's going to be in this interval in here, from negative 2 to 2, but it doesn't say or equals 2, so we are going to not include those those endpoints. So yeah, we got x is an element of the set, and then the set would be all the values in between negative 2. Okay, let's try that again. Negative 2 and 2. There we go. Okay, there's number 5. Number 6 is also factored already, kind of like 4 was. I love seeing these because that just makes the whole process go that much faster. My roots here are going to be negative 3, 1, and 5. I'm going to create my number line diagram here. And I'm going to plot the roots on there. So I get negative 3, 1, and 5. So my representatives are going to be, let's see if you can guess. And you don't have to pick like the 10s and the 1s. You can pick anything you want as long as it's in that interval. I just like to try to keep things consistent here. So negative 10, I'm going to use 0. Between 1 and 5, I guess I'll pick 2. As small of an integer as I can, and then I'll use 10 over here. Okay, so if I plug in negative 10, I'm going to get a negative times a negative times a negative, which will be negative. Multiplying 3 negative numbers is going to result in a negative number. None of these roots are have multiplicity. They're all single roots. So if you're like 100% confident this is right, it should just alternate. Okay, but we will check just to make sure that we didn't make a mistake somewhere. But you are expecting this to alternate like this if you're pretty confident in the first one. So like if I plug in 0, I'm going to get a positive times a negative, which is positive. And if I plug in 2, I'm going to get a positive times a negative, which is negative. If I plug in 10, I get a positive, so it is positive. But the shortcut here is you got to be really certain that you got this first one right. But if all the roots are just singular roots, then this sign will just alternate each time. Finally here, we need to write our solution set, which is going to be everything that includes these positive intervals along with the zeros because it is greater than or equal to 0. So let me just kind of steal one of these other sets so I don't have to retype everything. So the ones that are positive is going to be in between negative 3 and 1. And we are going to use brackets here because we want to include the zeros in our sets. And then the last set will be from 5 to infinity. And on this one, we will use a parentheses because we can't actually get to infinity. So anytime you write negative infinity or positive infinity, you will always use a parenthesis. On to page 3. Just kind of doing more of the same here. Is this factorable? Okay, so I think what I'm going to do here to kind of clean this up a little bit is I am going to multiply both sides by 2, although as I'm looking at this, I don't think it'll really make a huge difference here, because if I don't think this is going to be factorable, so we're just kind of stuck with what it is, but that's okay because we don't have any other x's. So if I do set like x to the 4th equals negative 16, there's going to be no real roots there. Okay, so we're just going to say no real roots. So, it's kind of annoying that your number line is not going to have any x-intercepts on it, but the nice thing is that you only have to pick one representative, okay, because the sign will never change if it never touches the x-axis. So my representative here is, well, I'll just pick 0. It's probably the easiest thing to do. If I plug in 0, I get 0 to the 4th, which is just 0, plus 16 is going to be positive. So I know that it's going to be positive the whole time. Now, on one of the previous problems, I did go ahead and find the imaginary roots, where in this case it would be plus or minus 2i again. This isn't the same problem, is it? Yeah. Oh, no. It was minus 16. So that's why it worked out that way. Yeah, so if I wanted the imaginary roots, I'd have, like, let's see, the 4th root of 16. So 2 to the 4th of 16. Let's see, 2, 4, 8, 16. Yeah, so it would be, and it'd be negative. So we have, if, I'm not asking for the imaginary, I'm just kind of writing this down just like sort of like as an FYI. The imaginary roots, if I can spell imaginary roots are going to be plus or minus 2i. Just throwing it out there. I'm not going to, this unit, I'm not going to be really asking for the imaginary roots, and they don't really affect our solution set here. So, yeah, I'm just kind of, it's just extra info. But our answer here says, when is it going to be positive? Well, it's always positive. So our solution set is just going to be all real numbers. And the way we're going to write that, did I not write the answer for this one? I thought I did. I'll go back and add it, but yeah, our solution set is just going to be all real numbers, which if we want to write it as, or using set notation, we're going to say that x is an element of the set negative infinity to infinity. All right, number 8. Okay, we need to make sure that we got a 0 on the right-hand side, so I'm going to start by subtracting 30x cubed from both sides. And looks like we got a nice GCF here, so we'll start with factoring out at an x squared. Hold up. Right. Actually, x squared, no. We want to factor out an x cubed. Yeah, okay. That looks a little better. And so in order to factor that last trinomial, this one right here, we need to find two numbers that multiply to give me negative 30, but add up to negative 7. So that would be negative 10 and 3. So my factors are going to be x cubed times x minus 10 times x plus 3. So my roots are going to be 0, and that has a multiplicity of 3, which is not going to cause a bounce. It will cause like a bend through the graph. So the sign will change there, but it's worth noting. I don't want you to forget to check the multiplicities, especially when you have to start sketching the graphs. And then the next 0 will be 10, and then the next one will be negative 3. So here we go with the number line once again. I'm going to label my roots. Here's 0, here's 10 is over here somewhere, and then negative 3 is going to be here. For my representatives, I'm going to pick negative 10. I think I'll go with negative 1 and 1, and oh, I can't pick 10. That's like my go-to. So I'm just going to go 100. Okay, might as well go all the way to 100. So it could be any number greater than 10. I just like easy numbers to work with. 100 usually is a pretty easy number to deal with. So, okay, so let's plug these in. We'll start with negative 10. That'll give me a negative times a negative times a negative, so that will be negative. Between negative 3 and 0, I chose negative 1 as a representative. So that's going to be negative times a positive. So that'll end up being positive. We don't have any even multiplicities, so just like the last few, where I talked about this, we are expecting alternating signs, but let's be safe here. Plug in 1, we get a positive times a negative times a positive. So that's going to be negative. And then if I substitute 100 in, I've got a positive times a positive times a positive, so that will be positive. So in this problem, we're looking to see where this polynomial is less than or equal to 0. So that's going to occur in this interval and in this interval right here, where it's negative. So let's go ahead and I'm going to steal one that has 2 intervals here. Just to give me a little template. Okay, so the first interval where it's negative is going to be in between negative infinity and negative 3. And we do want to include negative 3, but not negative infinity, because you cannot include negative infinity. And then my other set where the function or the polynomial function is negative is going to be in between 0 and 10. So 0 and 10, and there you go. So there's going to be our answer to that one. All right, there's number 8, and then let's move on to number 9. We'll wrap up page 3 here. Okay, so we definitely have a GC. Actually, you know what might be the way to go here? Is to divide everything by negative 6. That'll give us a positive leading coefficient. Now, if we divide everything by negative 6, though, anytime you divide an inequality by a negative, you do have to flip the sign. So just don't forget about that. So we're going to get x squared minus x minus 2 is less than 0. So just to really illustrate what I just did there, I'm dividing both this side and this side by negative 6. Okay, now when I divide by a negative, I got to make sure to flip this sign. Okay, so just that's not an error. That's what happens when you divide both sides of an inequality by a negative. Now I can factor this, and I get x minus 2 times x plus 1. So my roots are going to be at x equals 2 and negative 1. I guess yeah. Oh boy. What happened there? All right, yeah, my roots are at 2 and negative 1. So I'm going to draw my number line here. Try to get a little straighter line there. So here's -1, here's 2. The representatives that I want to choose are going to be, I don't know, -10. I'll go with 0 and 10. How about that? So if I plug in -10, I'm going to get a negative times a negative, which is positive. If I plug in 0, I get a negative times a positive, which is negative. And if I plug in 10, I'm going to get a positive times a positive, which is positive. Again, we have all these single roots, so we're expecting alternating signs. That happens, so that, that all checks out. And we want to know when this is less than 0, so it's just going to be in between here, in between -1 and 2. So I'm going to get x is an element of this set, come on, there we go, in between -1 and 2. All right, that wraps up page 3. We got, I think, 3 more questions left. So let's go on to the very last page here, starting with number 10. On number 10, now it looks, this is going to be a tricky one to factor, but you know what, let's just do it by grouping. And it's possible that it can't even be factored. We might have to use quadratic formula, but let's see if we can't factor this. So in order to factor by grouping, when you've got this leading coefficient of 1, we need to split up this middle term in such a way that we've got 2 terms that multiply to give me 4x squared, but add up to, multiply to give me 24x squared, but add up to -11. So in other words, we want 2 numbers that, oh, come on, give me the blue. There we go. 2 numbers that multiply to give me the product of 6 and 4, which is going to be 24, and add up to -11. So these same 2 numbers have to add up to -11. So it looks like the correct answer is going to be -3 and -8. Let's check that out. So -3 plus -8 is -11. Okay, so that's good. And then -3 times -8 is, in fact, 24. So yeah, we can go ahead and split up that -11x to be -3x minus 8x, and then the plus 6 will just stay there. Now we can do the actual grouping step by factoring out the GCF of the first 2 terms, which will be x, and we get 4x minus 3. And then the second one, we'll factor out a -2 and get 4x minus 3. Just like with that quartic that the cubic that we factored by grouping earlier, you want to just double check that what is inside the parentheses is the same, which in this case they are, so we know we're doing it right. The 4x minus 3 is going to be one of our factors, and the combination of the GCFs, the x minus 2, is going to be the other factor. So once we have this totally factored out, we can declare our roots. For this first one, if I add 3 and divide by 4, that's going to be positive 3 over 4. And then for this one, it'll just be positive 2. So we get 2 roots here. Let's try to make a straight line there. There we go. And so we've got 0.75, or 3/4, and 2 as our zeros. And so what we're now looking for is what's going on in between these intervals. So I'm going to pick my representatives to be, I'm going to go with 0, I'm going to go with 1, and I'm going to go with 10. So if I plug in 0, I'm going to get a negative times a negative, which is positive. If I plug in 1, let's see, I got a positive times a negative, which is negative. If I plug in 10, I get a positive times a positive. So if I'm looking for when it's less than or equal to 0, that's going to be in between 3/4 and 2. And since it's less than or equal to, we will use brackets instead of parentheses to write this solution set. All right, there we go. So it's not in between -1 and 2, in between 3/4 and 2. All right, we're going to redraw this, this little box here. All right, so there's your solution set for number 10. Oh gosh, looks like we got a typo here. It looks 11 through 14. 9 through 12. This should be 11 through 14. I guess, I don't know what happened there. But we've got this function. Let's go ahead and just factor it just right off the bat so that we can hopefully answer the follow-up questions. It'll be x plus 1 times x plus 1, so like x plus 1 squared. So we're going to have the roots. I'm going to do this analysis first, and then we'll answer all the questions. The roots are going to be just -1, and that's got a multiplicity of 2. So what that means is that my sign is not going to change at the 0. Okay, we'll hit 0, but since we have a bounce on the x-axis, it's going to not change from negative to positive or vice versa. So I'm going to label -1 on my graph here. I'm going to let my representatives be, I guess -10 is good. Let's see, -10, and I'll use 0 for these two intervals. Again, I'm expecting that these two signs will be the same because we have that bounce action going on. So let's plug in -10 and get a negative times a negative is positive. So I'm expecting the next one to be positive as well. And then if I plug in 0, I get a positive times a positive is positive. So it's almost always positive except for when it's 0. So if it's saying for what values of x is f of x less than 0, well, that never happens. Okay, never. Okay, it's never negative. Okay. For what values is it greater than 0? Okay, so here we're going to use this set notation. I'll just copy something like this. So it'll be in between -infinity and -1, and in between -1 and basically everything except for -1. In fact, when we have a solution set like this where it's everything except for 1 or maybe a couple numbers, it might be easier to write it as an inequality. You know, I've been writing everything as using set notation, but if I wanted to write as an inequality, I could just say x does not equal -1. And this is a case where the inequality is probably going to be more efficient than the set notation. So writing it either way here is fine. For what values is f of x less than or equal to 0? Again, never. Or equal to 0. So I guess, you know, technically at -1 it's equal to 0. So that's the only place where it's less than or equal to 0. So we'll just say x is -1. And then for what values of x is f of x greater than 0, that's going to be everything. Greater than or equal to 0. Because it's greater than 0 here, greater than 0 here, and then it's 0 here. So the answer there is going to be, you know, all real numbers, or we'll just say, if we're going to use the infinity note or the set notation, we'll say -infinity to infinity. And I believe that's the last question. So this one was a pretty tough homework. I'm not even going to lie. Some of that factoring is really, I mean, it's going to put your skills to the test here. You really have to be on your toes as far as making sure you get the factoring correct. That's probably the hardest part of this whole deal, is knowing, you know, just recognizing, like, when can I factor out a GCF? When am I going to have to use grouping? You just really make sure you get those factors correct. So yeah, I guess that's it for today. As always, let me know if you guys have any questions or if any of these problems didn't make any sense to you. And other than that, y'all have a great day, and I'll see you next time.